11.2%. Okay, so first the word percent, right, means per 100. So percent is really just like a ratio. Okay, it's something out of 100, per 100. Okay, so with percents, when you're talking about something like 4 is 16% of 25. Okay, you're comparing 4 to the base of 25 by writing the proportion to say that this is something, right? Percent is its own ratio, so 16 per 100. You're comparing the number to the base. The percent of a number, this is your denominator, and this is your numerator. The number that is something is the numerator, okay? So it means that 4 over 25 can be written as 16%, or as a fraction, 16 over 100, or as a decimal, 0.16. These all mean the same thing. They all mean 4 out of 25, okay? When you work with percents, you're usually going to use the fraction form or the decimal form. Because this is a symbol, it means per something, okay? We don't know what it means. It's per, well, we do know what it means, I'm sorry. But you can't work with it as a percent. You need to turn it into some sort of number. So usually your fraction or your decimal, okay? So with percents, a verbal model will help us, okay? So verbal model usually says the number being compared is a percent of a base. Okay, so if we assign labels, then we can say that the number being compared is A, the percent is P, and the base number is B. Okay, percent has no units, and the number being compared and the base have to have the same units. So, and then an algebraic model simply says that the number being compared is a percent of the base. Okay, A equals P times B. The percent is a decimal or a fraction. It cannot be left as a percent. Okay? So all of our percent problems are going to come down to this model. The number being compared is a percent of a base number. So A equals P times B. Okay? So what is 150% of $200? Okay, well what, don't know what is, right? That has to be your variable. So what, we don't know, is always means equal. Percent, we're going to make it a decimal. So you move it over 2 places to the left. So 1.5. Of means to multiply. And then this number. So x equals 1.5 times 200. When you multiply that out, we get 300. The number being compared and the base have to have the same units. So we would say $300 is 150% of $200. Okay? Then 26 is 40% of what number? Okay? Filling this out, right? Just translate it directly. So 26 is a number. Is always means equal in math. 40% as a decimal, you need to move it over 2 places to the left, so we would get 0.4. Of means to multiply, and then what number? We don't know, so it's our variable. Okay, so 26 equals 0.4x. Get x by itself, we're going to divide by 0.4. So 26 divided by 0.4 is 65. And there aren't units, it's just a number, so we're fine leaving that as just a number. So 26 is 40% of 65, okay? It all comes down to the same general problem, right? These look very similar. It's just a matter of where does your unknown go and where do your numbers go, okay? So translate it like you've translated every other word problem. Is equals, of means to multiply, okay? One more. So 48 is what percent of 160? Okay, so just translate this directly. So 48 is a number, is means equal, percent we don't know, of means to multiply, and then 160. So 48 equals P times 160. Get P by itself, we're going to divide by 160. And 48 divided by 160 is 0.3. But remember, this is asking you for a percent. So now we're going to turn our decimal into a percent and say 2 places to the right, that is 30%. So 48 is 30% of 160. Okay? So these are our three, if you look at the bottom of your notes here. Okay? These are the three basic forms. What number is a percent? Percent of a number, and the percent itself. Okay? These are the general forms. Percent problems all come down to this for us for now. Okay? Being compared is equal to the percent of a base. Just plug in the two numbers you're given and solve for the third, like you've solved your other problems before. Okay? Isolating your variables. So those are our percents.